This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about LAMIs Theorem, supports and support reactions, and free body diagrams. Let us see the LAMIs Theorem. It states that if three forces acting at a point are in equilibrium, each force will be proportional to the sine of the angle between the other two forces. This is the statement given by LAMIs. So for understanding this statement and how to represent the forces that are being concurrent and to identify the resultants or the unknown forces in the system, let us see the procedure how we can obtain that. The representation of three forces that are concurrent is given like this. Let us consider the forces P, Q and R acting at point O, and alpha, beta and gamma are the angles in between them as shown. Then LAMIs theorem can be expressed by the equation P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. The proof of the statement can be given using the in-order representation of the forces acting at a point O. The three forces acting at point are in equilibrium and can be represented by three sides of a triangle taken in the same order as shown. The angle between P and Q is gamma. So, the inner angle will be 180 minus gamma. Similarly, for the remaining forces. Now, from sine rule, P by sine 180 minus alpha is equal to Q by sine 180 minus beta is equal to R by sine 180 minus gamma, which can be written as P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. Thus, the LAMIs theorem can be proved. After this, let us learn about a constraint, action and reaction. Consider a metal ball of weight W resting on a frictionless surface at point A. We can understand that because of the surface prevailing, the ball cannot move downwards. The horizontal surface restricts the motion of the ball in downward direction, and hence the surface is treated as a constraint. Also, the ball applies a load of its own weight onto the surface of point A. This is called action of a constrained body on its support. And according to the Newton's third law, the surface exerts equal upward force on the ball at the same point A, where there is action. The upward force exerted by the support onto the body is called as reaction, represented here as RA. Now let us learn a very important aspect called free body diagram. This is a very useful tool for solving the problems in engineering mechanics. It is described as a sketch showing only the forces acting on a body by removing the support elements is called free body diagram. For example, let us consider the figure from previous topic. Here, the surface is the support for the ball. By removing this support, we have shown the reaction offered by the support at point A as RA. Drawn normal to the body, that is, the ray drawn here is perpendicular to the support. The actual forces acting in the system here are the weight of the object W alone. So, we have represented the force W at the same point C. If at all any other forces would have been acted on the ball, then we have to represent all the forces at the same point of application of individual forces. This is called as free body diagram of the system. We will come to know in detail how to draw free body diagram while we solve the problems. After knowing about the constraints, actions and reactions, now let us learn about various types of constraints, supports or the support reactions. First type of support is called as the frictionless support. That is, this is a simple type of support which we have discussed in the previous topic. The flat surface acts as the support and the free body diagram should be represented as discussed previously. The second type of support are the roller support and the knife edge support. These are also the point load supports as shown here. The reactions at point A and B are shown in the free body diagram here towards and normal to the body. These supports restrict the downward movement of the body. And the third type of support is the hinged support. In this type of support, the body is restricted to move in x and y axis directions. So, there will be two support reactions at the hinge point. The final reaction will be the composition of the reactions XA and YA. Next type of support is the built-in support, also called as fixed support. In this type of support, the body is fixed at the support point. There will be no movement in any direction at the support point. So, along with the X and Y axis direction reaction, there will be a moment reaction at the support as shown here. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.